Good morning. Today's video lab, Getting Wired Lab. The handout looks something like this. Read along as I read aloud. Purpose is to build a model that illustrates electric current. So we're transitioning from static electricity to electric current. Discussion: while we float on a raft gliding down the Mississippi or riding cars moving in traffic, nobody can see current flow. Even in this case of lightning, we are seeing the flash of hot glowing gases produced by electric current, not the current itself. However, we can infer the presence of electric current using light bulbs and magnetic compasses, in much the same way that a flag indicates the presence of wind. In this activity, you will build a model to study electric current. Okay, so the essence is you can't see current, but we can see its effects. So that's what we're going to be doing. First section. Three D cells set up in series, and then two resistors in the form of light bulbs set up in series. And it says, is there any visual evidence that something is moving in the circuit? So if you get to where you can see both light bulbs, and I'll complete the circuit, and they light up. And I'm connecting, unconnecting, connecting, unconnecting. Then the next question, does one bulb light before the other? And does one bulb go out before the other? And is one bulb brighter than the other? And it seems to me that the answer to all of those is negative. They light simultaneously, they go out simultaneously, and they're both of equal brightness. Pause. Section 2 says to place a magnetic compass on the table near the circuit, needle pointing north, and I want the end to be lined up. And then we want to rotate this and then I'll connect the circuit and that supports the notion that something is happening in the wires. And you can see the bulbs both lighting, but you can also see the compass deflecting. And it's deflecting in a certain direction. And it's a significant amount of deflection. So now we want to move the circuit and see if the part of the circuit affects the deflection. And it doesn't. Okay, so all three parts deflect the same magnitude and the same direction. Okay, in section B, we're going to try to figure out a directionality, because right now we know there is a directionality, but we don't know what's affecting it. So I'm going to reverse the leads of the battery. And we'll see what happens. Make a prediction. And if you'll notice, reversing the leads affects the direction of the deflection. Hey, that rhymes. Magnitude is still the same, but the direction has changed. Now, what will happen if I use 2 batteries instead of 3? The bulbs aren't as bright and the deflection isn't as great. What about 1 battery versus 3? The bulbs are dimmer and the deflection isn't as great. Okay. Then I'll put the leads back to the original position. Is it Monday? And it deflects the original direction, original amount. 2 bulbs instead of 3, or 2 batteries instead of 3. Doesn't deflect as much, and the bulbs are dimmer. 1 battery instead of 2. Bulbs are way dimmer and the deflection is smaller. So that does it for the data collection of this lab. Hopefully you have a bright idea now of what's going on in the wire, and you should be able to answer the analysis questions. And have a good day.